Here, I would like to explain something that's called synthetic division. When we think of the word synthetic, we would sometimes think fake or something along those lines. Here, the reason it's called synthetic division is we drop off a lot of the detail from our polynomials and instead we just use the coefficients. The first step to synthetic division is we will write each polynomial in descending order and be sure to include any kind of missing powers by using a 0 and then x to whichever power we're missing. To perform the synthetic division, I want to make sure to use what I'm going to call the 0 of the divisor as my divisor number. That would be the C value that I'm talking about here. When we set up synthetic division, we will put the C in a box, and then we will take only the coefficients off of my polynomial and list them to the side. We're going to leave a blank space in here and then draw a line, and then down below we are going to end up eventually with the coefficients of the quotient, and then the very last thing I'll have over here will be my remainder. This is hard to look at or envision without actually doing an example, so I'll do an example. When we actually write our answer down, the answer is going to be written the same way as the other problems in this section, where you basically say that your function that you're talking about is equal to the divisor times the quotient plus the remainder. The trick is here, whatever the degree of your original polynomial is, let's say it's n, the actual quotient will always be 1 degree less. So if we know we have something that has a power of 4, then down here the answer would have a power of 3. That's something important to remember. I'll show you as we actually work the problems. Okay, so let's look at this problem here as an example. One thing it is important to make a note of is that synthetic division does not always work for any division problem that you have. Notice that this divisor has the form of just x, and it could either be plus or minus a number. There cannot be a value other than 1 in front of the x, and then also you cannot have a power larger than 1 on the x. So it's important that this particular divisor is x minus 3. If you look back up at your notes, then we said synthetic division is basically a shortcut, but can only be used when divisors have this form. An understood 1 in front of the x, no power larger than 1 on the x, and then plus or minus a constant. Alright, the first thing we want to identify is what our C value will be. We get the C by setting this equal to 0. So if we set that equal to 0, we'd get x is equal to 3. 3 is going to be the value that I use for C. Put that value, 3, in kind of a half box. Now, notice that the polynomial that I'm wanting to divide has coefficients 1, positive 5, and negative 7. Notice also that that polynomial is in descending order. It's not missing any kind of powers of x. So what I'll do is to the right of the 3, I will write down my coefficients, 1, 5, and negative 7. From here, leave underneath that a blank line, and then draw an actual line. From here, to perform synthetic division, you have certain steps that you must do. The first step is whatever the first coefficient is, you need to bring that number down below your line. So bring below. From here, you would take that number and you would multiply it by the 3, the C value that you have up in the box. Once you find that product, so this would be 3 times 1, you put the product under the 5. Now we add down. So 5 and 3 is 8. Once you have a number below, you would then multiply that number by the C value, in this case by 3. So we would do 8 times 3. 8 times 3 is 24. And then once you have the 24 up above, you would add down. And so here, negative 7 plus 24 would be 17. Now this I'm actually going to circle as my remainder. Notice that the degree of my original polynomial was equal to 2. These values represent the coefficients on my quotient. The degree of this polynomial will always be 1 less than whatever degree you have here, so this degree would be 1. So to write our answer down, we would write p of x, which was our original x squared plus 5x minus 7 equals, what did we divide by? Now we put all the x's back in. We divided by x minus 3. And we're able to see that by taking the opposite of this number here. Then you're going to multiply by the quotient. These values here represent the quotient. The 1 is the coefficient on x to the first. And then the 8 always has a power less than that, so that would just be 8, x to the 0. We don't write x to the 0, but just 8. And then we would write plus the remainder. In the final answer, we won't write the ones, so you just have x minus 3 times x plus 8, and then plus 17. So the general idea for synthetic division is you take out all your x's to actually perform your division. However, you make sure that you have everything in descending order. If you have missing powers, you have placeholders. When you perform the division by using this, I'm going to say, method of bringing down and then multiplying up and then adding down and so forth, then you need to know where your answer or what your answer is. The last number here being your remainder is very important. And then here, the 1 and the 8 you see are the coefficients on your quotient. And so there it's important to know what those values represent. And then because they don't have x's with them, it's important to know what x you start with. Well, here, the degree you start with is always 1 less than the degree you were originally given in your larger p of x function.